bytes. If you want to filter content just instantly, then, well, buying a machine with that much memory to be a mail server is a bad idea. So you will need to distribute things or find efficient, interesting data structures how to distribute it. And that's where then the nice math comes in again, where you can prove theorems. So don't worry. You want to distribute the optimization part, synchronize the model, and do a lot of other things. So for instance, maybe my spam preferences will change over time. So maybe at some point I might decide that some administrative email is maybe not quite so exciting, right? So it really therefore means that you want to have a personalized model and you want to distribute it. Okay. So we're almost through the data part. Just to give you a bit of an idea of, because sometimes people think, okay, you know, large-scale machine learning on the internet, well, that's just how you solve a classification problem in a very scalable fashion. Or, you know, how you do naive Bayes very quickly, or how you can cluster very quickly. Well, it's usually already defining the problem that's the hard bit. So I can show you in this class specific crystallized options of, you know, ways how you can solve a problem. To address a very specific application, you will actually have to model the thing. So to give you a bit of an idea where you might actually have implicit labels with ads, you do get clicks. You might actually also get some tags. With emails, well, the fact that I might have deleted that email unseen just by looking at the subject might be a good indication that it is spam. Then sometimes people tag things, like on Delicious they used to do that. One thing you should really avoid if you possibly can is editorial data. It's about the worst possible thing you can do if you can engineer another way around it. So here's why. It costs you a lot of money. As you need more of it, it costs you more. Furthermore, you will possibly be able to find very cheap editors for the English market, but then what about the Canadian market, right? What about the maybe British market? Maybe what about the Indian market, where they also speak English, right? They all have very different preferences. Or what about some entirely different languages? So therefore, don't start with editors if you can possibly avoid it. Use them possibly to validate your system, but never as active data generation mechanisms. At least that's my piece of advice. Okay, we're on camera.
So can you say what editorial data is?
Okay, so here's an example. Suppose I want to build a spam filter. All the privacy concerns aside, I could go and pay you to, you know, go through thousands of emails and label them as spam or not spam. Or what you could also do, and this is actually what is to some extent still being done for machine learning ranking, I, you know, would type in queries like, well, write up queries like machine learning. And by the way, here are 100 links. Rate the links based on how relevant they are for machine learning. And so then you pay some editors, which usually tend to be women in their 20s, for whatever reason, to label queries. So in other words, up to some time ago, essentially whatever women in their 20s decided was relevant was what, for instance, Bing or Yahoo would use as search results for their content recommendation engine. Now there's nothing wrong with women in their 20s, but the thing is it doesn't necessarily very accurately reflect the entire demographic of who might come to your search engine. So this is the other danger, that you will induce editorial bias simply because the editors may not really know your customer base as well as the customers do on their own. So if you can possibly avoid it, try to elicit information from the users as opposed to paying somebody to label it. In some cases, labeling is very cheap, so Mechanical Turk and Amazon, for instance, is a good way of getting labeled data. It may not be very high reliability. Then there are very clever mechanisms, and so Luis van der Aan, for instance, has done great work on things like CAPTCHAs, where you basically get humans to solve labeling or data generation problems for you. And then this actually poses a whole bunch of rather exciting statistical questions of, you know, suppose I start with, you know, text that I need to recognize. How can I guarantee that the humans who label it actually label it correctly, and how can I still distinguish, you know, those from spammers? So that's not an entirely straightforward question. It's basically, you're basically trying to estimate the label of something without ever having anybody telling you, well, for sure this is the correct label. So these are ways how you can actually generate a lot of labeled data, but you need to come up with a good mechanism design to do so. So if you don't have to do it, even the better. Now there are a lot more data sources. So this is a very dated slide, and you can see it stops essentially data in 2003. But this is basically stratified per sensor size the cost of a camera. And you know, of course, more megapixels cost more dollars, but what you can see is they all keep on decaying. And what it basically means is that by now you can get devices which record 5 to 10 megapixel data for very little money. So for instance, the camera up here, which is going to record in high definition video, costs $300. And this is going to produce about 20-25 gigabytes of data just from a single week's worth of lecture. All this data is going to be stored and logged somewhere, and somewhere you want to analyze it. A fairly exciting thing of what's happening right now, this is the sequencing cost per megabase for a DNA sequence, and basically here's something very exciting happened. Basically the Human Genome Project accelerated things rather dramatically. This was Moore's law, and we can assume that maybe in 2 years or so, you know, they'll break below the $100 for a sequenced genome base threshold. So I think recently a device for $1,000 per sequenced genome was announced, and so I think it's going to happen very soon. This is another pair of devices. So for instance, here's a networked thermostat, and you will get a lot of those devices in your house which will generate data which you want to analyze. And this turned out to be a not so successful thing, basically Jawbone Up wristband, which tried to basically be an activity monitor, and they pretty much refunded all the cost. The key differentiator to everything before is that this data will be in the cloud. So in other words, it will actually be accessible by a central processing mechanism, like, you know, a big cluster of machines, and where you can then pool data from many users together and analyze it. Okay. So now is probably a good time for a break. If you have questions, do ask now. Otherwise, we'll reconvene in 5 minutes.